Hello everyone, this is Sam Schmidt, your instructor here at Bellingham Technical College. Today we're going to be covering an introductory lesson in the Oxy-Fuel Torch Assembly. So before we begin, one important thing, as always, is to make sure that we're wearing the appropriate PPE for the job at hand. That would consist of long sleeves made of natural fiber, long pants, and what you can't see in frame is that I'm also wearing work boots. Accompanying that, I have a cutting shield in the form of a weld hood that in this case is auto darkening, and I can set it to shade 3 or 5, which is ideal for cutting with Oxy-Fuel. And then I also have appropriate cutting gloves for the job. So once you are assured that you have the appropriate PPE for the job and you find yourself a bottle cart, when you're approaching it, we're going to make sure of two key things. Primarily, we want to make sure that the bottles are secured. If you can see in frame, there is a chain holding the bottle into the cart to make sure that it's stable and that it doesn't get knocked over on accident. The second thing that we want to make sure that we're aware of is what type of gas that we are using. Now, these are Oxy-Fuel cutting torches, so oxygen is standard. However, there's a multitude of different types of fuels available for Oxy-Fuel cutting. What we're using today is what's known as propylene. Other forms of fuel that are commonly used are propane and acetylene. Now, propylene, propane, and acetylene all have different burn characteristics with different temperatures and different stoichiometric ratios. That's something that we'll be covering in a later lesson. Today, we're going to be focusing primarily on setup, safe operation, and safe shutdown. So, we've assured that the bottle is secured. We've also assured that we are using the correct gas. And now we can put on our PPE. Along with the auto darkening weld hood, what can also work is a cutting shield, such as this, or you can have cutting glasses, the dark tinted safety glasses, and a clear face shield. However, safety glasses and some form of a face shield are required at all times. All right, I'll do my best not to turn my back on the camera here. However, some of it is required. So, before we begin and before we pressurize our lines, a quick rundown of what an Oxy-Fuel cutting assembly consists of. As previously mentioned, we have oxygen in our fuel, in this case propylene. Those are in pressurized tanks that are held securely. Those are then passed through regulators to where we can regulate the temperature that is flowing through the lines. And here we have our torch body with our mixing chamber, our adjustment valves, and finally our cutting tip. So before you begin any cutting process, whether it's your first time or your 9 millionth time, we want to make sure that we're inspecting the equipment to make sure that it's in safe condition to use. All of the tools and equipment here at BTC are phenomenal. However, they have quite a few miles on them, and you never know whether it's in due of repair, I'll put it that way. So, making sure that primarily the lines are in good condition, regardless of where you're working at. It's always a good idea to make sure that some ding-dong didn't drop a hot piece of metal on it. Once you've assured that everything's in good condition, you can check the size of your tip and appropriate to the size of the material that you are cutting. That's something that we'll cover more in depth in either a separate video or a separate lesson. However, the tips are numbered numerically, anywhere from 00 being the smallest, all the way up to something like 19, which would be for cutting several feet thick material. The primary tips that we'll be using here in the shop are 00, 0, 1, 2, 3. So making sure that you have the appropriate size tip and that you know the appropriate settings. There's a chart located off behind the ventilation, which I can show you in person in class, that lists the different settings for the different thicknesses of material, the different tips required, and then each one for each different type of gas. This might be a lot to take in, one little step at a time. So, after you've made sure that everything's safe and ready to go, you can go ahead and turn on your bottles. So one thing to note is that it's important to make sure these regulator screws are backed out. They don't need to be so loose that they're falling out, but just freely spinning. When you're cracking open a bottle, it's important to make sure that you're staying out of the blast zone. So essentially this line of fire that exists from where the valve is. If for whatever reason something was to go wrong, you want to be standing behind the valve from where the regulator is. When you're opening this bottle, oftentimes they're pressurized to over 2,000 psi, and 2,000 psi worth of force is hitting this regulator. If something was to go wrong, you want to make sure that you are not in that line of fire. So as you crack it open slowly, you'll watch the temperature rise. We have two gauges here. We have tank side or high side, which is showing us the pressure in the tank, and then we have a low side over here. This is what's showing us our line pressure. This is what we'll be setting shortly to do some cutting. So same procedure for the fuel. Oxygen, however, you can open all the way. Fuel is a different procedure. When you're opening fuel, same concept, standing out of the line of fire, but you only need to open it 1/8 of a turn, maybe a quarter. The idea being, if for whatever reason there was an issue, let's just say your line gets severed by a hot piece of metal and there's fire going everywhere, which does happen, you want to be able to come over here at the source of the fuel and shut it off quickly. You don't want to be spending 30 seconds turning it and turning it and turning it just to get the fuel source to shut off. So again, same thing. Two gauges on the one valve, my apologies. You have a high side and a low side. High side is our tank pressure, low side is our line pressure. When we're starting them, we've backed out these regulator screws, so the line pressure should be 0. Now, when we are cutting something, we are going to be setting our line pressure to what is determined on the chart. In this scenario, I'm not actually going to be cutting anything just yet. We're just focusing on safe setup and operation. So I'm going to set this based on a predetermined number. All right, so making sure that the valves are closed and that we're not just leaking gas into the atmosphere. The torch, these particular torches have 3 different valves. You have a fuel valve. You can see the red line is indicative of fuel, and the green line is indicative of oxygen. So we have a fuel valve, we have an oxygen cutting flame. This is for maximum oxygen pressure, and then you have a neutral flame adjustment knob up here. And I'll explain what that means in just a moment. Once we get the flame lit, essentially you have what's called a neutral flame, and when you depress this cutting lever, it adds the additional oxygen and initiates a cutting flame that then permits us to cut through various forms of metal. So without getting too in-depth and too pedantic, when you are igniting the torch, what you want to do is making sure everything's closed, slightly crack open the fuel, ever so slightly, and then use your striker and ignite it. So if you'll notice, it's easy as pie. It's just like it's like a hefty candle. If you have too much fuel when you're trying to strike it, what can happen is it'll actually flood the striker, and it throws off the stoichiometric fuel to air ratio, and it won't ignite. Usually what happens then is it will ignite at some point further out where the gas is dissipating, and then turn into a whole nother issue. So it's always better to start with less fuel and then go up. All too often people aren't getting it to strike, and their first reaction is to add more fuel. That's not always the correct route. So when we have our fuel flame going, propylene in particular is rather finicky. See if I can get this to show up on camera. If you'll notice, as I add more fuel, the flame is actually separating from the tip. See if I can get that to focus. There's a gap there, a negative space. So that is indicative that we have too much fuel to start adding oxygen. If we start adding oxygen at this point, the flame will just pop and go out, and then we gotta start back over. So what we wanna do is make sure we're turning down our fuel to where that flame is touching the tip. And then we're gonna open up our oxygen, about 3 turns, more or less all the way. And if you'll notice, it's not changing the flame at all. That's because, again, this is the cutting oxygen that is for this cutting lever. We're gonna adjust, now that we've turned that all the way open, this neutral oxygen lever right here. We're gonna crack that open ever so slightly and watch as the flame changes. So if you'll notice, the flame has changed quite a bit. It's much more blue. You can see right here, if I can get this to show without burning the camera, we have a blue flame and we have bright blue little cones in here. So as of right now, these cones are very, very short. Propylene, as I was mentioning for the initial startup, is rather finicky. What you have to do is sort of step it up. So we're gonna add a little bit more fuel and then a little bit more oxygen and a little bit more fuel and a little bit more oxygen as needed as we watch the flames. So as we're adding fuel, you can notice those bright blue cones are getting larger and dissipating more. So this is a flame with too much fuel and not enough oxygen in the ratio. As we add more oxygen, oops, other way, it sharpens up. Now when the flame has too much oxygen, which I'll demonstrate now, you'll notice those bright blue cones almost turn like a purple, ever so slightly. This is an over-oxidized flame. We want somewhere right in the middle. Now the other thing is that I didn't prep or clean this tip at all, and you'll notice each of these little cones are different lengths, different shapes. They're going different places. I don't know if you can see that on the camera. So that's indicative of a dirty tip. That's got spatter, that's got debris, that's got everything in there. This needs to be shut down, depressurized, taken apart, and cleaned with a tip cleaner, which we'll talk about in a separate lesson. But for now, set up, safe operations, safe shutdown, fundamentals. So, as we have a tip that's dirty, this might be less representative, but what we're shooting for is these bright blue cones to look like ice cream cones. They should have that same angle, the same slope, the same consistency. Unfortunately, this is one part of the welding fabrication industry that's quite a bit more feel-based than it is scientific. I can't say specifically, turn this 723 degrees. Every torch, depending upon use, is going to be a little bit different. So making sure that you're observing and adjusting as needed. So now that we have this about as close as it's going to get, considering how dirty these tips are, I'll just add a little bit more. You'll notice this is what's called the preheating flame. We have this cutting lever right down here. When you depress that, it adds a full force of oxygen, what we set at the regulator. So this flame is used to preheat the metal, and this is that's what's used to cut it. I'm not sure if you can hear me with that going. So when you're ready to cut the material, you warm it up, back just off the edge of the material, depress that and start cutting. We want to make sure that we're keeping this tip off of the material. You don't want to be touching or dragging the tip onto the material. Those bright blue cones should be about 1/8 of an inch above the material, whatever you're cutting, regardless of thickness. We'll talk quite a bit more over the course of our year on cutting techniques and on troubleshooting and things like that. For now, if we're approaching the shutdown procedure and we have a lit torch, what are we going to do? We're going to make sure that we are shutting the oxygen off first. You want to starve the flame or starve the fuel of oxygen. So we're shutting off the oxygen first, and then we can shut off the fuel. If you shut off the fuel first and then the oxygen, what can happen is flashback or burn back, and that's usually demonstrated with a loud popping. If you hear a loud whistling as well, what that is that's the flame actually burning back inside of the tip. Now, all torches should be equipped with what are known as flashback arresters, and this prevents that flashback from burning back in the lines and back to the tanks. It's essentially a reverse flow valve, think of it that way. So making sure that those are on at all times as well. Those should be installed either within the torch, oftentimes torches will have them built in, or in this case when they're not, they should be installed as an auxiliary on the line. You can see also there's flashback arresters that are positioned here on the regulators as well for the reasons that I mentioned previously. If some ding-dong drops a hot piece of metal on here and the line catches on fire between the torch and the bottle, it's important to also make sure that the source of the oxygen and the fuel is prevented from any mishaps. So Accidents happen, but they can always be avoided with some safety and things like that. So making sure that after we shut this off, we make sure that everything's closed. Be mindful that this is very hot. The tip of the torch burns at over 5,000 degrees, more than hot enough to burn through your gloves. So making sure that you're not grabbing it. It also makes the tip quite a bit softer than it normally would be. So be careful when you're going to set it down. Don't bang it around. It's not a hammer. So as we set that down, we're going to come over here and we're going to do what's known as the shutdown procedure. We're going to close the bottles, first things first. And part of our shutdown procedure is always bleeding the lines. So removing any of the gas that's in the torch lines. We've now shut off the source. Now we can open up the valves and let all of the fuel and oxygen out. Again, imperative that you make sure that the bottles are shut off, otherwise you'll just be sitting here for anywhere from several minutes to several hours filling the atmosphere with explosive gas. So making sure that that's closed, and now you make sure that these are closed as well. So once everything's closed up, we can look at the gauges on the regulator. Both the high side and the low side, the tank and the line, should be reading 0. No pressure in them whatsoever. Now, crucial step that's most often missed by even second-year students is to make sure that we're backing out these regulator screws. So we want to loosen these regulator screws, again, not till they come out, but just till they spin freely. The diaphragms inside of here are spring-loaded. They're essentially like a rubber diaphragm. If tension is left on them, and you open up this bottle at full 2,000 plus PSI, it's going to hit that diaphragm, and it can cause the diaphragm to burst or explode. Hence what we were talking about at the beginning of setup with staying out of the line of fire. So again, making sure these are backed out, making sure everything's closed, everything's bled, and then the other thing that's equally important is cleaning up and putting away. Now that the bottle cart is all reassembled, I can roll it back to where it came from. Thank you, everyone.